Hello, welcome to the data channel, and you're watching ChatGPT for data professionals. And as part of this video, we will be discussing about generative AI. And so you might have definitely heard about generative AI by now, and so you should be wondering, like you might have all definitely heard about ChatGPT as well. So basically, ChatGPT is a kind of generative AI. So we will understand what is generative AI and what are the key concepts, techniques, and applications where the generative AI is being used. So it is not just ChatGPT, right? So there is a lot of applications, a lot of tools and techniques that are being developed using generative AI. Not it's having a lot of vast applications as well. So we will discuss those in detail in this particular video. Before proceeding, if you are new to this channel, we would recommend you to please subscribe and also press bell button for instant notifications. So let's get started. So when you talk about generative AI, so generative AI is nothing but, as the name suggests here, right? So it is nothing but it's a generative and then AI. So there's two words here, right? So AI is artificial intelligence, and generative means it generates something using artificial intelligence. That means generative AI is a subset of artificial intelligence, right? So it is intelligence is old concepts, is already existing from almost a decade or so, right? So the generative AI is a subset or sub domain of artificial intelligence. It's been developed and it's been like very famous after it's been very popular after the chat GPT came into picture. But so it is a subset of artificial intelligence, right? And so what exactly it generates, right? It can generate like images, right? It can generate text, so it can generate music and other data, right? So like it can do a lot of operations, right? As we said, like what are the things it is generating? It can generate images, audio, video, right? And text, very importantly, right? All this data it can generate. Basically, that's what we say. So it is generating something. So it is not generating just by like it is generating using its own knowledge of artificial intelligence. It is some generating it's using creativity, and it is having its own knowledge base. It is having its own trained models, right? So based on that, it generates the audio, video, images, text, etc., right? And see if the difference between artificial intelligence and the generative AI is artificial intelligence is it is not used to generate anything, right? So it is used to maybe sometimes predict, sometimes analyze the data, sometimes do some kind of a predictive analysis or exploratory analysis based on the data it has, and it is to train the model and refine that model to use that. But here the difference is in the generative AI case is it is generating the data, like it can be images, audio, video, etc., right? Text, etc. So that is what generative AI is doing, and these models, whatever are used, are are learned over time based on some patterns and structures from the large data sets. So how it is generated? So using a large data sets, we have a large data set. So suppose you are generating an image, right? So like there will be large data set of images. Maybe it can be taking from the web, extracting from the web. Suppose like all these images are which are there, the millions, billions of images, it will get trained using these images or audio, video, text, etc. So it trains using a lot of models and patterns and structures from this large data set, and use this knowledge to produce a kind of accurate or near accurate or novel kind of output that resembles the original data. So the why we are saying it resembles the output original data is here. See, using this, what generative AI is doing is it is generating an output. Okay, so this output, the final output, uh, is resembling the original data, or the expected, the reality resembles to the reality, what we can say, right? Suppose like you ask ChatGPT, I want to know what are the top 10 um, like waterfalls in India or in USA, whatever, right? So it can give you the list of top 10 waterfalls, and it can give the like what is the which is the longest one, and what are the in feet, in meters, all of that data it can give you. But in reality, those facts and figures might be different. So that is what we call as a hallucination. So sometimes if it will try to make it as near to reality, but it might be not exactly similar to what in reality is, so based on the facts and figures, right? So that is why it is called as hallucination. Okay. And so that is why we need to be careful when you are using like ChatGPT or any kind of AI tools, and we cannot completely rely on that data. You need to verify that whether, especially on the facts and figures when you are using it. And it depends, like the quality of how closely it resembles to the reality depends on how the generative AI is trained, how much data set is it being trained with, right? The more the volume of the data, the more the accurate the results might be. And also there are different models, different techniques, right? That also makes it closer to the reality, right? So with that, we will switch to what are the key concepts and techniques, right? So GenAI has these are the key concepts and techniques for GenAI. So it is GANs, that is Generative Adversarial Networks, and we have a Variational Autoencoders, and we have transformers and diffusion models. So these are the key techniques. We can say there are other techniques as well, but these are the very basic, and these are the core techniques of generative AI. And whatever you see today in the market, the tools, the techniques, including ChatGPT, so all more or less use these kind of techniques to build their applications or tools, right? And today in this video we will go through all of this, okay, in detail, and with the examples and where exactly they are applied. And so that you will come to know, like, it is not just the chat GPT, but how exactly extensively the generative AI is being used, right? So let's get started with GANs, that is Generative Adversarial Networks. We call it as GANs, right? We will see, like, basically, if you want to understand this, right, it has been so it consists of two neural networks. So the first is a generator, and other one is a discriminator, right? And which are trained simultaneously, basically, right? And suppose if you take here, so one we call it as a generator, and another we call as a discriminator, right? So what happens is, these are trained simultaneously, and the generator creates a new data instance, and while the discriminator evaluates them, whatever is generated by generator, and evaluates them for the authenticity. It's like a developer and tester, if we really want to kind of so the generator is generating, and discriminator is kind of validating it, and giving it feedback back to the generator, so that it can refine itself. So the generator improves its output based on the feedback given from the discriminator. So this feedback loop leading to the generation of high quality of synthetic data, or the artificial data, right? And what are the different applications and examples of this, right? So first one is image generation. So GANs are used in image generation, and the example is DPART, and the DPART uses GANs to create a artwork by applying the style of one image. For example, if you are having a Mona Lisa painting, right? So it can replicate the Mona Lisa painting to a context of another. So where example of take another person photography, and it can produce a stunning artistic rendering that blends Mona Lisa painting with some other person's photograph, and it can blend together and create a new data or new picture, for that matter, right? So that is what deep art does using the GANs. And one more is a deep fake technology. So this is also what it example is face app, which actually uses the GANs to alter facial features in photographs, such as changing the age, gender, and adding a smile, for that matter, and even completely changing the face of a person with replacing with uh, another person face, and it can convincingly modify the image to produce it like a look like a more realistic in nature, right? And we have text to image. So text to image synthesis, where we have a famous thing that is a DALI. So it is developed by OpenAI, and DALI generates the images from textual descriptions. For example, given a description like say for example an armchair in the shape of an avocado. So that's a description, right? And so DALI can create a corresponding image for whatever you are giving the description. Okay, so that is what the DALI does, where we are calling it a text to image synthesis. And next is a video generation. So where the example is deep video portraits, this application uses GANs to create a realistic video portraits, where the head position, facial expression, and lip synchronization can be kind of a controlled and altered based on the new input video, or maybe also images, right? And the next is a music generation, where one of the application called Muse GAN is uses again a GAN based model to generate a music by learning from its data set of existing musical pieces. It can create a new composition also that reflects the style and structure of the training data that's been fed into it. Okay, and we have a 3D object generation. 3D, the example is 3D GAN. This model generates a 3D objects from random noise or 2D images. It is useful in gaming applications, creating virtual reality, and maybe computer aided design, what we call it as a CAD applications, right? These are the applications and examples of GANs, wherever the GANs models are being used to develop the AI based applications, right? And next we have a variational autoencoders VAE, where we will again see the applications and example for these things. So basically, variational autoencoders are usually the powerful generative models that learn to encode data into latent space and then decode it into generate a new data sample set. So if you see the examples like so image generation and reconstruction, and example is MNIST hand written digits. So where VAs are often demonstrated as on the MNIST dataset, which consists of handwritten digits. The model learns to encode the digits into a latent space, and can easily generate new realistic looking digits by sampling from this space. Okay, and even we have a like face generation. So example is celeb A data sets. So where VAs are trained on the celeb data sets, can generate realistic human-like faces. These models learn the complex distribution of human facial features, and can create new faces that resembles maybe real real celebrities for that matter, right? And next we have image in painting. So this is a contextual image. Example is contextual image completion. So where EVA can be used for image in painting, which involves filling in missing parts of an image. The model can generate content that fits seamlessly with the existing part of the image, right? So wherever it is missing. And so anomaly detection. Next, it can also be used in anomaly detection in the industrial inspections, where VAs are used in manufacturing for anomaly detections by training on normal data. The model learns the typical variation that can occur, and can also identify anomalies when presented with new data that derives from the learned distribution. Right. So that is where the anomaly detections are being kind of used, or anomaly detection can be created. Applications based on anomaly detection can be created using VAs. And next we have a text generation. Example is a sentence variational autoencoders, where we also call it as SVAs. And this uses VAs can be applied to text generation by learning encoder sentence into a latent space and then decoding them to generate new sentences. So this approach can produce coherent and contextual appropriate text. So this is again related to text generation, right? And we have music generation also, where VAE is like Google's music VAE is a model designed to generate and also interpolate musical sequences. It can create new music also by learning the latent space of the musical compositions and generating novel sequences that are musically coherent to each other. And with that, we will next move to the transformers. So, like transformers are heavily used actually, if you in the current reality, because say for example of the Chat GPT. So, Chat GPT is also derived from the transformers, right? And transformers originally designed for NLPs. So that is why we talk about Chat GPT, right? Chat GPT is based on the mainly on the natural language processing, and have been adapted for various kinds of applications across multiple domains, right? So that we will see here. So first thing is the famous natural language processing, which is NLP, where we talk about ChatGPT 3 4.0, which is developed by OpenAI. So these are the models will generate like human-like text and can be used for a wide range of applications, including chatbots, content generation, language translation, and code generation, right? And ChatGPT base model, ChatGPT 3 and 4.0 provides conversational AI capabilities. Basically, the conversational means you can ask prompt. You can prompt the ChatGPT and ask the follow-up questions. So that is the main thing of using the conversation. That is a conversational AI is what we call. And we have a machine translation, for example, BERT from Google. So it is nothing but bidirectional encoder representation from transformers. So this is used to improve the machine's translation by understanding the context of words in search queries, enhancing the accuracy of translations, right? And we also have a text summarization, where the example is T5, that is text to text transformation transformer. So this is again developed by Google. So this is a T5 converts various NLP tasks into a text-to-text format, making it highly versatile for tasks like summarization, translation, and question answering. And we have question answering, where Albert A Light BERT is an optimized version of BERT. Albert is used in tasks requiring high level of understanding and reasoning, such as reading comprehensions and question answering. So next we have protein folding. So this is again example is AlphaFold, which is developed by DeepMind. So AlphaFold uses a transformer-based architecture to predict protein structures with high accuracy. So this has been revolutionizing the field of bioinformatics and also helping in drug discoveries. Um, so next we have text-based games and simulation, right? So this is nothing but example is AI Dungeon, right? This interactive text-based advantageous adventure game uses ChatGPT 3 to generate dynamic storylines and scenarios based on the user input, and providing more immersive gaming experience. So these are the majorly for the transformers and its application and its examples. Okay, and the famous is the most popular is definitely the ChatGPT 3 4 by OpenAI. And now we have a diffusion model. So what exactly diffusion model, and what are the tools and techniques, or what are the applications that are being used or created using diffusion models, that we will see. Diffusion models are basically are a class of generative AI model, or a type of generative AI model that iteratively add and remove noise to create new sample data set. So here are some like there are a couple of examples that we will see. So diffusion model is nothing but, so you train a particular data. So you have a data, you train that data and generate a output. Okay. And again on this data you generate a noise. Okay. You add a noise, again train it, add a noise, again train it, add a noise, again train it. So it is being trained by adding the noise, right? It might sound crazy, okay, but that's how the technique and the model, the particular diffusion model works. And what are the different examples, we see DDPMs, that is denoising diffusion probabilistic models. So this is basically um, mostly used in image synthesis, where DDPMs have been used in generating high quality images from noise. So they work by gradually denoising and random noise vectors to create a coherent image, right? And we have OpenAI's DALI 2, which is a text to image generation. So here DALI 2 leverages diffusion models to generate images from the textual descriptions. So you might all be already aware. So you give a text and it will DALI 2 will generate images for you, and it improves upon the original DALI by producing more detailed and high resolution images. So that is how the DALI has improved over the time. So initially, if you have used DALI when it was released, it was giving the result or images, but it was not so clear, or it was having a lot of noise. But now it's been trained to generate a high quality images, because it is having it's been learning over the years now. Okay. And then next we have a super resolution. So where SR3 is an example where super resolution through repeated refinement. So SR3 developed by Google again, and it uses diffusion models to convert low resolution image into high resolution ones. The model progressively denoises an image, enhancing its resolution while maintaining high fidelity. And next we have image inpainting. So inpainting with the diffusion models, again diffusion models can be used to for image inpainting, which can involve filling in a missing part of an image by denoising an image with missing regions, right? And we have a style transfer. So for example, a styled image generation tool can be created using diffusion models, can be applied to style transfer, where the style of one image is applied to the content of the another by controlling the denoising process. So these models can create images that contribute or combine content and style in novel ways. So finally we have protein folding and molecular design. So where diffusion models in bioinformatics, these models can be used to predict a protein structure or design in new molecules by iteratively refining noisy molecular representation to generate a valid and functional biological structures. So these are the examples that are being explained, right? And power of diffusion models is generating high quality data across various domains, right? And maybe it's images, audio, video, text, etc. Okay, so with this explanation, let us move to the summary part of it, right? And we will see, like we discussed about GANs. These are like more into the generating the realistic data through a competitive framework, right? But can be unstable to train, because it is having a generator and a diffuser and generator and discriminator we have here. And now next is VAEs. So VAEs focus on learning latent representation, right, and are useful for tasks like image inpainting and anomaly detection, especially the anomaly detection. And transformers leverages a attention mechanism for handling sequential data and excel in tasks like language modeling and translation. That's where ChatGPT is. And diffusion models iteratively refine noisy data to generate high quality output, usually for the task like image synthesis and video generation. So this is based on as we discussed, like it based on the it get trains based on the different levels of noise. So in this video we have discussed what is generative AI and what are the different techniques, or what are the different key concepts that are being used in generative AI, creating the generative AI tools and applications. And also we have discussed about all these the core key concepts that are being used in building the generative AI tools and applications. Hope this was useful. Thanks for watching.